two crates of mass 75 kilograms and 110 kilograms are in contact and at rest on a horizontal surface. A 730 Newton force is exerted on the 75 kilogram crate. If the coefficient of sliding friction is 0.15, calculate the acceleration of the system and the force that each crate exerts on the other. All right, so I just went ahead and already sketched this for you. Let me throw in the force there. So the force on this thing is 730 that we're pushing on it. And notice how it asks for the acceleration of the system. In physics, when I say the word system, it means we view these two objects as one, right? Would the answer be any different if it were two boxes, or if these two were somehow glued together and were just one object? You would get the exact same answer. We can treat them as one thing as long as they slide the same and they're similar. So I'm going to do that. So I'm going to kind of redo the problem as if we were just pushing one box. So we have a force of 730 that's being exerted on one box with a mass of 185 kilograms. It's the same stinking thing. We'll break them apart later if we have to, but for this analysis, that greatly simplifies things. All right, so first of all, we got to find out what the force diagram is on it. So we've got a downward force caused by gravity. I'm just going to use the approximation here. So 1,850. If you want to use 9.8, you'll get a similar answer. The normal force is going to be equal to it because the boxes aren't going to slide through the floor or anything like that. So 1850 here. And then we've got the push that we're exerting on it, which is 730. And then we've got a backward force of friction that's just going to oppose the motion. All right? And we know that, I'll kind of run out of room a little bit. I'll draw it down here. We know that the force of friction is equal to mu times the normal force. So it's just going to be 0.15 times 1850 is the force of friction that opposes it. Let me crunch that really fast. For force of friction, I get 278 newtons. So, sorry, running out of room here. 278. All right, so you're pushing it this way with 730, and the system has friction that opposes that push with 278. So if we want to find the net force on this whole thing, we just do F net equals MA. The net force between these two, hopefully I don't have to tell you to know it, you just subtract them, right? If you pull this hard to the right and that hard to the left, you get a net force of 452 newtons to the right, and then you use the mass of the whole thing, so equals 185A. And then to get A by itself, you just divide both sides. Hopefully you're used to the drill by now. I got 2.44 meters per second per second. So that's the first part. Second part's a little weirder. It wants to know how hard A pushes on B, and that's going to be the same as how hard B pushes on A. I'm going to pick block B to see how hard A pushes on B, because if I redraw a force diagram just for block B, check out what the forces are. We have a downward force caused by gravity, which is going to be 110 times 10, so that's 1100. We have an upward normal force that's the same thing. Right? We have a push this way that's the push of A on B. It's just the contact force between them. And then we have a backward force of friction. All right, but we can calculate that because we know that FF equals mu times Fn, which we just get 0.15 times 1100. So the force of friction is 165 newtons. So 165 here. And we know that F net equals MA. And F net is just going to be the force of A on B minus 165 equals MA. I'm out of time. You figure it out yourself. Good luck.